And welcome back, people. I hope you had a great time yesterday. Well, I know that actually during the labs, for this certification, DP203, um, it's a bit sometimes not so straightforward, and you might have experienced some, let's say, maybe complication, difficulties, and that's perfectly normal because the setup for the data architecture in those labs are not so straightforward, and therefore, no worries if you had some difficulties on that side. You just have to get through it, patience, people, and then little by little you'll get through it. No worries. And we are here always to help you out there. Then, but now let's come back to the theoretical part. My name is Crux Perez. For those who didn't get it or catch it at the beginning, I'm living here in Mexico, a beautiful country, and actually, those days were quite, or it's quite um, lots of things going on, socially speaking, lots of fiesta, things like to celebrate. And talking about celebration and making parties and on those dates and those times, I'd like to ask you something, people, before we jump into our two next modules today quickly because, well, we have a quite pretty big agenda, of course. But I always like to maybe make some breaker now and then. Here we go. For this time, for today, I'd like to ask you something. I'm gonna put here on my screen, on my screen sharing here, one question that I hope you guys can just answer. It's a very simple question about your own taste. So here we go. Let put me here. The question is, what is your favorite food? Um, you can answer that. Please answer that going to www.menti.com. Again, www.menti.com. And you just use a code 5268 Okay. When you go on this web page, will be asked for a code, and you just have to you just have to put this code and answer that little question. What is your favorite food, guys? About me, well, I obviously like lots of food here. International food, I'm all kind of I appreciate international food. I can see here already some answers: pasta, ramen, sushi. Oh yeah, I definitely like those ones. Pizza, definitely. I mean, maybe pizza is maybe the most international appreciated dish, right? The plate. I mean, stroganoff. Stroganoff sounds like East European, Eastern Mexican food. Wow, nice. Yeah, Korean fried chicken. Oh yeah, I tried those. Right? Salmon, grilled fish, biryani, and KFC. Nice. Oh, pad thai. Oh, pad thai. I ate that just before yesterday. Paella from Spain. Nice. All right, you got a lot of answers. That's nice. Grilled fish. And actually, I'm living here on down at the coasts, and we have definitely have um, seafood. And yeah, burek, burek is, I guess, Turkish, right? And you see here what other thing, Hyderabadi biryani. Okay, that's down, I guess, in Asia, like near Indian, right? Sadia, perfect. Peruvian food, yeah, definitely like ceviche. We have actually here in Mexico also ceviche. Um, okay, it's run up. Yeah, perfect, perfect. Nice. Always nice to see and maybe discover new plates from around the world. That's very something very interesting. flambe nigiri. I didn't want this one. Jerk chicken. Yeah, I heard about this one. Perfect, guys. Perfect, perfect. And then in the meantime here, okay, and still have other. I'm gonna keep those answers definitely. Burning coal, okay, and borscht. Yeah, that's from. I mean, I would say maybe Russia, of course, but I know there is like some discussions between like actually countries over there between Belarus, Ukraine, Russia, and even Poland about where borscht comes from. So I wouldn't say straight away borscht is Russian because I know that people, countries are like fighting for it. Um, Mafe, yeah, yeah. Like, I know that it comes from like Cameroon or Senegal. Got some African friends when I was in France. Mafe, yeah. Socido, perfect. Good, guys. Unfortunately, I have just to then change and go back to our topic here. So we get that for me. Definitely, if you want, then later on I can give you maybe a screenshot about all the foods here. But anyway, we let's go forward. Two modules today. It's gonna be mainly focusing on Azure Databricks. Okay, Azure Databricks here is a big topic regarding, as I mentioned yesterday, machine learning, um, doing things and stuff essentially with, let's say, big data science, right? The data engineer has to know how Databricks is definitely connecting, how it works, so he can put in place, set up all the data architecture, right, for the data scientists so they can to take advantage of its capabilities. Okay, so we're gonna see here and deep diving into data transformation through Databricks. Okay, I'm gonna explain you the capabilities of it so you can understand what it entails. Sorry, yeah. How to actually read data and write data. So through various techniques. And finally, I'm gonna give you an introduction to work with data frames. Okay, data frames in Azure Databricks. So it's let's say not a framework. It's more like an API and library to work with data. It's actually through Python. Okay, and using data frames, we're gonna see some advanced methods like data time manipulations. Okay, in the lab, you're gonna have the opportunity to explore how to use various Apache Spark data frame methods. Okay, and you will learn how to perform standard data frame methods to explore and transform data. Okay, so that's basically it for this module. That's what we're gonna check out, and that's why here you have this agenda. Let me put here my laser pointer. So here we go. Understand Azure Databricks. As I mentioned, read and write data in Azure Databricks, data frame, right? And then we, as I mentioned, advanced method in Azure Databricks. So let's get into the first lesson, understanding a bit more Azure Databricks, okay? So this slide, as you can see here, gives you another view about the data services integrations that Databricks offers you, all right? That's on this side here. As I mentioned, this is more for actually your role here as a data engineer, how to integrate Databricks. So you have different, actually here, runtimes engine, okay? Um, and actually in the lab for this module, you will experience working with notebooks, okay, in Azure Databricks, and you will create data frame, and you will cover actually more aspects of Databricks in later modules. So don't worry if you might think like, okay, I think there's a lot of more things to see, but you will see that in later modules. Okay, it's actually in the module 15. Create a processing solution with even hubs and Azure Databricks. So you're gonna see that later on in the last modules. So to come back to this actually slide, okay, you can see here that Azure Databricks is fully managed, okay, cloud-based, obviously big data and machine learning, okay, platform. It's gonna empowers actually you as a developer to accelerate your AI, okay, and innovations by simplifying the process of building any data application you need to. So definitely integrates with other data services, okay, and you should be actually familiar with those other services like Azure Data Factory. In Azure Synapse, you have actually the pipelines, which is the same as here, the factory, but you can definitely connect those components between them and with Databricks here. Finally, Power BI will be able to be connected to Azure Databricks, so visualize the data or any data you are building here. And finally, here you will be connecting your Azure Databricks to a data lake storage to get the data from. Okay, so it's built as a joint effort by the team chat that actually Apache Spark, because we were talking about Apache Spark yesterday, and Apache Spark, remember, is done by the Apache organization, which is an open source organization, but as a joint effort with Microsoft, they actually built this Databricks, okay? And it's gonna provide the data engineers one single platform for big data processing. Okay, that's what you have to understand here. And it's gonna provide the data scientists, okay, this platform to build their machine learning models. That's at the end the value that what Databricks brings. Databricks, yeah. Okay, so different runtime engine. What is a runtime? It's basically what is gonna make your, uh, let's say, programs or any application run, or any, let's say, workload running. Okay, so you have different runtimes for machine learning here. PyTorch, which is used with Python, TensorFlow, scikit-learn, and then you have the underneath runtime engines, which is based on mainly Spark. Okay, Delta Lake, we talked about it a bit yesterday, and input output applications, and definitely a serverless engine to be able to quickly query the data. Okay. Second lesson here, how to read and write data in Azure Databricks. Now, we're gonna see here Azure Databricks that can actually read multiple file types. Okay, here you have CSV, Parquet, JSON, and many others type of format. Okay, it can read them with or without a schema. Okay, and in addition to that, actually Azure Databricks can combine inputs from files and data stores. For instance, Azure SQL database, Azure Data Lake Storage, which is not a database system, but you can combine them and read it together and actually also from Azure Synapse Analytics, remember, done for data warehousing. So you can do that within a notebook, okay? Notebook is something where you're gonna be able to do many things. I'm not sure if you have been already, if you have some experience with working within a notebook, but it's something specific. You have like notebooks, Jupyter notebook, etc. But that's very convenient when you want to write some code, when you need to at the same time work with a data set and any kind of explanation and graphics you want to put also. So notebook will be very useful in that environment. So that's also something you're gonna be familiarized with, notebook. Okay. What should I say? Yeah, within this notebook, you're gonna have actually multiple language support. So you can write, for instance, you code in Python, and then a bit more, later on you can write in Scala and R, etc. Um, well, you can actually view data frames. So data frames would be, let's say, as I said, an API. An API. What is an API? It's something that provides you access to a program or let's say an application through some, let's say, functions, right? If you have been familiarized with programming, you know that you can access object, especially with object-oriented programming, like through some methods, right? So the same thing here, API are like, okay, I want to get into that object and give me this functionality or this data. And for those who are not familiarized with those, API would be like an interface, right? When you go, for instance, on a machine and you can get information from a machine by pushing this button. So that's what would be an API here, basically. You push the button and you get some information or you get some actions done, all right? So data frame would be this kind of API where you would be able to work with data. And you can see, actually, you could see data frame here in Azure Databricks, like you might see that in, for instance, a spreadsheet, Excel spreadsheet. Okay, so it's like a box with squares in it, and it organizes data, which could also refer to as table of data. That's what is a data frame. It's a single set of two-dimensional data. Okay, you can have multiple rows. So let me just change here my laser point with a pen, and yeah, that's basically what it should look like. You know, like data frame is basically this. You have your table with columns, and it's a set. I mean, this is just a part of a bigger data. Let's say of data warehouse, like you have many tables and many columns, but you create your own data frame here. So just a part, right? You have, well, this is just like, I would say here, a big table, like a fact table, as I mentioned yesterday in the data warehouse. And you can take with a data frame a part of it, right? Or any table. I mean, doesn't mean it doesn't have to be a fact table, but you have some tables here, and actually it can be a jointer, so you can join some tables and make it in a one data frame. Okay. And yeah, you're gonna have rows that are information about what you're considering. Okay. So what would happen though if you have thousands and thousands of boxes here? Because let's consider those tables as boxes. Well, data frame creates a data structure, and it's one of the core data structure in Spark. Okay, so in Spark, a data frame is seen as a distributed collection of data that is organized into columns, and those columns obviously have names. So as you start reading and loading data that is actually unstructured, it means not necessarily in a table, but have like uh, key value, key pair value, key value pair, right? Or semi-structured. That would be the case, and it can be structured. So anyway, the data frame would take this information from all those kind of type of data, and it can start transforming the data in order then to gain insights. That's what you want. You have this mishmash or mix mash data that are structured, not structured, and obviously they are in a blob storage, and eventually in let's say I would put that it sounds like a database, but it's not. Maybe should I write draw it a bit differently, but let's say this is a storage, right? A blob storage, blob. Consider a blob storage is like a big container where you can put any type of data, okay? So you take those information into a data frame. That's what's happening, okay? And you do that in the way you can gain insight. Therefore, it's gonna be structured in, let's say, in a table format. Doing that, you use generally, can I write it here? No, okay. Spark, okay. You can use Spark SQL. SQL language, remember, is structured query language. So anything regarding to select from where those little statements. If you have no clue about what is a SQL language, let me explain you quickly here. It's a language that basically gives you the opportunity to question the machine or the your computer. Give me the data that refers to that person, or give me all the sales of the last month, etc. So that's what provides you SQL. And Spark SQL is a declination, it's a flavor of a SQL, because there are many flavors of SQLs developed for Spark. Okay, so you have also PySpark. It's another library for Python. Where's my cursor here? Yeah, here it is. So PySpark is another thing that you're gonna use to create those and manipulate those data frame. Okay, PySpark. Okay, so that's what you need to know here. You're gonna do that generally with a notebook, and you're gonna use those languages, Spark SQL, PySpark, and you're gonna create data frame to have insights to read and write data. All right, so here is an example using actually Scala, talking about languages. Those line of code you can see here are Scala, but it can be performed with other language, such as Python. Okay, so there are three steps here. That's the first step here. Let me again put my laser, not my pen. Here you go. The first step here, second step here, and the first step here. Okay, three steps here to read data in Azure Databricks. Okay, we're gonna read. So you connect first here to the underlying data store. Okay, so that's the connection here. Connection. Then you have the second step, which is creating the data frame. Okay, we are creating here by actually declaring df, all right? And this is gonna create a data frame. Spark read dot options, and then you're gonna say the header. You want the header and dot CSV because it's in the CSV format. ABFSS, that's the file system also format, and then you provide here the address, the URL. And URL is a unique reference link that gives you the path to get to your file. Okay. And finally here, the third step is to display the data. That's quite pretty straightforward. Display parentheses df dot limit, because we're gonna actually limit the rows. If not, you have a big problem there regarding your workload. Charging, loading all the rows that you might have over there is not maybe the best idea if it's a big table. So limiting always is good. Limiting to 10 rows, for instance, so you have a sample, a little samples here, right? And that's the results here. You have just read data in Azure Databricks. That's how it looks like. Remember, first you connect, okay? Then you create a data frame, and then you display this data frame. That's very pretty straightforward steps for reading data in Databricks, okay? You can actually read more about those steps. If you go on Microsoft.com on the documentation, you just have to put read write in Databricks, Azure Databricks. Okay, just put read and write in Azure Databricks, and you're gonna have more information about how you can or how you should actually put the syntaxes in Scala or any other languages. Okay. Now here is a showcase. Okay, it comes with actually a comparison of SQL and data frame with Python. Remember, you have on one way here on one side the SQL language, and data frame is a library of Python which allows you to work with data frame. Okay. So there is a comparison here, okay? You have the ability, for instance, to filter data by rows and columns, to sort data, to create aggregation here. So first thing first here is just reading, selecting some data in SQL. It looks like you have to put this. Why doesn't it? Okay, just a second. I'm gonna put the pen. Here we go. No, it doesn't work. And is it okay? Yes. Okay, select. Select is a keyword in SQL from. So you select the column you want, and you have to specify the table. On data frame, when your data frame is created, you just here take the data frame and you select dot select, and then you specify call and the column name. You have something as a describing thing, so you're gonna print that with data frame, etc., etc. Aggregation is grouped by, same thing in the data frame Python language, group by. Grouping by is, as it says, you want, for instance, to group by your data by, for instance, I don't know, by month. If the table is including a month column, or grouping by customers, right? If you have many rows and many purchases or sales to customers, and you just want to know how many in total, so you're gonna group by the customer, and then you're gonna order by if you want to a certain type of order. You can set some conditions, right? I just want data that are considering after this date, 1990, etc. And you want to limit the results up to 10 rows, and you want to display your table in text format or HTML. Same thing here. Okay, so you can definitely see this information again on Microsoft.com, the documentation, docs.microsoft.com. If you go on work data frames in Azure Databricks, just put those keywords, Azure Databricks data frames, then you will have those, let's say, syntaxes, how to work with SQL or with Python. And finally here, again, you're gonna have the steps to go and write data. Now it's writing data in Azure Databricks. So first, again, you connect to the underlying data store. And then you create here your data frame. Then here you can manipulate the original data frame with a select statement in Python. And it's going to create a new data frame. Okay. And you can display it definitely optionally if you want, so that at the end you're going to write out the data frame results file. You're gonna have to, let's say, save it somewhere to make it persistent. So you write that in some file, like a CSV file. Okay, so here you have 1, 2, 3, 4, 5 steps to write data in Azure Databricks: connection, data frame creation, and then here you manipulate. So you're selecting what you want to get. I mean, what you want to write. Here you can display it so you can see what's going on, and at the end, write it. Perfect. Let me see here just a bit. Okay, got a lot of questions over there, but my wingman here, my partner Brianna, is taking care of that. Perfect. And I know many questions will pop up definitely, because we're talking here about complex things. But remember here, the first step is to give you an overview, what's going on, how to write data, how to read it first, right? With some steps, general steps that you can see here. And afterward, you're gonna have some details, more and more details. But this course here is really to provide you the basis, right? So you to know what's going on, what it is for, what you can do, why, etc. And a bit of the how to do that, you have seen a bit here. Now let's continue with working with those data frames in Azure Databricks. Okay. All right. So these slides here shows you some code, uses again in data frame API Apache Spark, and it's a single command actually here. All of those lines are a single command, right? So it's a special format when you are programming. So don't be scared. Don't think like it's, wow, what's going on here? It's one single command. And above, you can find an example of data frame called page counts actually here. Okay, page count and ODF. And in the code being created, you're gonna use actually Spark read method here, and it's gonna read a Parquet file. Okay, so first you're gonna read, but what you're gonna read here with saying .parquet and then saying here which one, because it's gonna returns an instance of data frame. Okay, so that's how it looks like when you, for instance, want to read data frames in Azure Databricks. Okay, and don't worry, you're gonna actually have some lab instructions over there when you're gonna do the lab session, because anyway, Apache Spark Data Frame API is a really rich set of functions like select, filter, join, aggregated, as you have seen. And you just have to know little by little how to write them, the syntaxes, because it's gonna provide you some solution to solve your data analysis problems, right? Or what you want to do. So you can use, again, as I said, Python, SQL, R, and Scala. What I recommend is to stick maybe with one language at the beginning, because now here we are going into the technical aspect, and it involves to be efficient or to be skilled in some other, let's say, domain. So to not get lost and to not be confused by the different syntaxes, just choose one, like Python or SQL, for instance. In my case, I was a lot with Python during my study when I was younger, and I studied for computing science. I definitely began with SQL, but later on I started to be familiarized with Python. And here again, you have you have a listing of, for instance, here in SQL, sorry, not SQL, but in data frame in Python here, the functions and transformations available, okay? All those transformation options are gonna be in the lab, okay? Select. It's gonna be able to specify the columns you want to include in the query. You can drop any columns you don't want them. You can take the values that are distinct, that are not repeated. You can drop duplicate values from a data set. You can show, right, some data from the one you want to choose. Or this one is similar to show display, but it's, as it says here, a bit more flexible, because the downloading results against the CSV is rendered with charts and showing up to 100 rows, okay? And you have another one which is limiting the record that you want as a data frame, okay? So, how to optimize data frames in Azure Databricks? As soon as you get here, the let's say, well, the essence of what you can do with data frame in Azure Databricks. Um, Here you can also have an example of, for instance, a mixed data frame operation. Okay. So this slide shows you code that uses a data frame API, and you will find actually example of data frame called this page counts and ODF, and it is cached. And what it does, it's performing accounting. Okay. So as it says here, actually in the comment, mark the data frame as cached, and it's counting the rows or the data that is materialized in the cache. So just an example how to optimize, for instance, the data frame. And again, you're gonna see that in a lab. Okay. All right, guys. So we're almost there, and we are going to the final lesson of this module, lesson 4, work with data frames with some advanced methods. Okay. So we're gonna actually see some example of advanced transformation methods. And they are quite commonly used among in the real life with our customers. Okay, so in the lab, you will actually dive into those notebooks examples of those codes, and each of the advanced methods would be actually over there explained, and you're gonna use them. Okay? So that's what you're gonna have to do later on in the lab regarding, for instance, data time manipulation, aggregation functions, and deduplication of data. Okay? Um, for data time manipulation, sometimes you're going to need to normalize data where different data frames, data time, sorry, formats have been used. And you can use different functions to manipulate the date time and use it across actually the data frames. Okay. Now, aggregation functions. And as I said, you can aggregate your data, especially when you work with big data. So that's what you want. And when there is a question, for instance, of the total sales, you're gonna then use, for instance, the sum function, or when you want to group by your data, as I mentioned previously, by customers, by a geographic area, for instance, you're gonna use this group by function. You have average, you have minimum, you have max functions, giving you the minimum of a set, maximum of a set. So those are the transformations you can do, right? What should I say? Well, just know about those main functions: sum, count, average, and minimum, max. That's the first steps just to when you start to learn data frames methods. And you will be actually on your way to learn the yeah the functions in that data frames Python, for instance, here. Okay. All right. So questions time. 3 questions for you guys. Just think about it. You can answer in the chat definitely. But if not, I'd like really to think about those questions. I'm gonna give you a bit of time. How would you list files in DBFS within Notebook? Remember, well, we haven't seen actually this function here, but okay, no worries. If we haven't seen that, then I'm not expecting you to know the answer. Maybe you have seen that on your own, or if you have been already working within the Azure Databricks. But the answer is not straightforward if you haven't been familiarized with it. So let me just show you the answer here. And it's a bit technical. Yeah, I grant you that. But here the percentage FS is the starting way to say, okay, we're gonna using this file system, and ls is actually, let's say, like a command let to say list. Then you have a slash my file path. Okay, then you're gonna have here to provide what you want to list in which location. That's gonna be the variable part. You have to replace that my file path by the location, the path where you want to get your files listed. Okay. Second question: how do you create a data frame object? And remember, we actually see a bit of those in the previous slides. So it's quite a very not so complicated answer. I mean, you just have to think about what was done when one wanted to create the data frame. I'm going to give you a bit of more time to think about. Remember, we were connecting first to the data source, and then we had it to create the data frame by putting something very, let's say, when you know how to, when you are familiarized with programming. And the answer is just put a variable name, like a name, my data frame df, for instance, equal to. So that's it. That's the way you start to create a data frame. You have to name it, you have to declare it, and then you you say what is gonna be that df dot, and then you creating your data frame here. I see here Maston say var df, definitely. So I like that's the idea here. You just put the name for the data frame. You have to store actually the result of the data frame somewhere. And finally, third question, you need to find the average of sales transactions by storefront. Oh, this sounds like something. By which of the following aggregates would you use? So actually here, and I accept the answers if you say that in SQL, which is quite straightforward, but the answer here would be in Python language. uh, the, let's say, keyword is quite similar to the SQL keyword. Just you have to put actually at first your data frame as an object, then you put the dot, like the method you are using, and then you are saying, okay, which column you are specifying there and what kind of aggregation you want to complete. So that's here the idea how to think about in Python. So first you have your object, your data frame that you have just created here, both, right? And then you apply those methods because remember Python is also an oriented programming language. So you are talking about objects here. And this is here an object, right? You have created this object, then you use a method, okay? And I see here Mustang again. Yeah, you are all over there. You're quite close to the proper answer, but don't worry. I mean, the syntax is quite very specific as with any languages. So the idea is over there, what you are doing there. Yeah, that's correct. And let me show you here what would be the proper syntaxes. You have your object here, data frame, right, that you have created. And then you apply this method grouping by. So here first we're gonna group by. Maybe if you would have averaged first, I don't think it would work. The result would be the same. First, you have to group by. Then you say, how would you like to group by your data? By storefront. So that's why you have to put the keyword call, parentheses, and then it's always within quotes, double quotes. And then you provide here the column name storefront. Then obviously you close the parentheses because that's what it's an argument here. And you apply because it's gonna be, you can make it you can put that in a chain. You are chaining here your methods. So on top of that, what you want is to make an average by storefront. So that's why you can put here dot average, and you are averaging that on completed transactions, right? Because we want the sales transaction in here, for instance. I mean, this is very something that you should know on the database, on the data frame, right? For instance, the name would be on this column, completed transaction. Double quote, close parentheses. So this command or this yes, this instruction in Python would give you that, would give you the average of sales transaction by storefront, right? Again, it's a whole topic to know program, and this is very technical. Don't worry, for the exam, you don't have to know how to really code in Python or Scala, but just to understand the idea, right? So the question would be like, okay, you have here this instruction. What would be the result, for instance? So with intuition, if you get the idea here, yes, you would say, okay, I know that this is the data from object, and I know that we're applying methods here, or some things, some instructions like grouping by, because this is supposedly to be something straightforward, right? It talks to you grouping by, okay, here AVG is for average. All right. And then here it says like we are averaging on these column, etc., etc. So that's the idea, is that you need to just to understand and to know for the exam. We are not asking you to know how to plan, to code in those languages, but it's better if you know, definitely. You can actually get initiate into. There's lots of good courses about. And little by little, here, what we want you to really understand is how the instructions, the code is organized. So that's the way here, for instance. All right. Later on, you will be invited, of course, to get into the lab, right? To explore and get some transformation. So that's also a good opportunity then to get into it, to start to type some code and to get familiar. Again, my recommendation would be whenever you have time, try to get these beginning courses for Python, for instance. There's another one, Scala, or in my case, again, I liked to I get into the Python and SQL. Okay. And yes, data frame methods. Okay. Think about the data frame methods that we have just seen. That's what you're gonna see in the lab. Advanced tasks, removing duplicate data, manipulate date, time values, rename, aggregating data. That's what you're gonna see in the lab. All right. Um, Here is actually listed. Okay. Cache and data frame for faster subsequent queries. We're gonna manipulate those times, remove, rename data frame columns, aggregating data stores in the data frame, etc. All right, so let's get here this wrapping up this module. Okay, that was it. You have here questions for the lab. I mean, I can give you here again the answers because we have a bit of time. For instance, what is a function that allows you to print data to the console in Azure Databricks? Let me get that here with a pen. So the answer would be, you know what? I can actually maybe, yeah, okay, it's okay. I'm gonna put that in another tool, just a sec. Because this pen is not very useful when I want to write something. Here we go. The answer would be df.show. Okay. That's one function that allows you to print data, a very straightforward one. So again, remember, you put the object here first at the beginning, your data, df or my data frame, whatever, dot, because you are using here a function or a method to be more precise. And show is the one that allows you to print data. Question 2, how can you transform a whole data set called whole data set df data by selecting only 2 columns? So when you're gonna use the select statement and create a new data frame, just 2 columns of it, it could be like, let's set here only, for instance, 2df, that would be my data set, equal, and then here I'm gonna put the whole, let's say, data set that I'm getting from the data, and then I'm gonna put here what I want. I want to select it. Select, and then which column you want to select. So here I'm giving it a first argument, column 1, for instance, with the codes. Don't forget the codes, are very important. And the second column, let's say. And closing the codes, closing the parentheses. That's how I would transform a whole data set into just my own data frame, right? My only data frame over there, uh, actually called Monly to BF. Well, it's a big strange name I've put there, but yeah, that's the idea here. Third question, what is a common function to use in order to look at data? And here I will talk about Python again. The one which is very close to the SQL language, and it's group by. When you're talking about functions, don't forget the parentheses. Put the parentheses, okay? And sometimes when you say, I want the function, use a function, but I want to give a parameter, this kind of parameter, you want to say, yes, I want group by, for instance, 2 or 3 columns. So that's where you're gonna put that within the parentheses. I'm trying here to explain the concept of programming to those who have no idea. So just think about what would be within the parentheses as like a parameter. You want to module the function that you are using here. And when there is no parameter, that's where your parameter will be without anything within it, right? Here, like in this case, nothing is within the parentheses. That means parameter. Okay. All right. So finally, we went through this first module of today. Okay. Uh, we have seen, again, I'm gonna put this one here. Azure Databricks, how to use techniques for transform and create your data frames, okay? And how to explore the data. Remember, first we connect, then we create data frame, and then we display, or we do some transformation before that. So I would say here, for instance, transformation, like what it doesn't mean. It can be, for instance, aggregation. That's a very common transformation. Or you just select some columns. You don't want all of them, etc., etc. So that's the type of transformation you're gonna be dealing with first. And again, it says here definitely you can visit the website to get more information about any methods we have seen today. Just put, yeah, Azure Databricks concepts. You can go on this Microsoft, it should be the link out there, Microsoft docs.learning, Microsoft.com, and you're gonna see over there many documentation about those methods for Python, Scala, etc. Okay. Good, good. We will jump on now to the second part of today, the second module of today, which would be module 4. And I'm gonna just give you 2 minutes, just very quick break, 2 minutes. I'm not even putting the timer here, but yeah, 2 minutes as a little break, and we will be beginning with the next module. All right. Okay, people. Giving you a couple more seconds for those who went for a coffee. And definitely we need coffee. I'm quite fond of coffee. And I like, those coffee quite straight ones. I mean, how you say, strong coffee, like in the European style. Here on this side of the world, North America, I find it very not so strong, quite well, low concentration. I don't like that. Actually, I prefer very strong coffee, like espresso, but in a larger quantity. That's how I do that. All right. So second module for today, the module five, module fifth, ingesting and loading data now into the data warehouse. Um, Now we're gonna switch and talk about a bit more about Synapse, but still talking about. We're gonna talk a lot about those methods, still being Spark, mood, etc. So uh, as as I mentioned yesterday, data warehouse means a lot Synapse. That's where you're gonna work with. But remember, Databricks is always using would be used using would be connecting to Synapse and using those data warehouses. So Oscar, I'm from Colombia, and the cup of coffee is an important step. Hey, for sure, my friend, for sure. Um, Here in Mexico, you have some places like Chiapas and Veracruz where they're producing some good coffee, but still, I guess, not at the same, maybe, well, at least maybe not quality or kind of things of Colombia because we are importing a lot, I guess, from Colombia, the coffee. Good. So, um, should I say here, yeah, data ingestion. Data ingestion here is a very important part of your role as a data engineer. Okay, it involves balancing the needs of what you get, I mean, the source systems, and you ensure that you do not disrupt those systems. And you balance that with the needs of loading the data on the other side into your data store, data warehouse, right? That it would be your analytical system. So this is here a bargaining power, should I say? Yeah, I've been a lot in the business analysis field, and we used to call a bargaining power between two parties, also in the sales field, right? When you want to bargain something. So you're gonna bargain with your data administrators over there with their database, SQL databases, and files stored on the file share system. So you're gonna go to see those guys and say, hey, I need your data. And they're gonna say, all right, you need my resources, you need the bandwidth, you need all those things. Of course I need them, but don't disturb me. Right? So at least don't disturb them as much as you can. I say. So that's the whole point here. How you can, how you should, as a data engineer, assure them or reassure them that you will be efficient and you will be discreet. Okay, gonna take your data, but I will not overload your system. Okay, so in this module, I'm going to show you some ingesting technique. It's going to include Polybase. Polybase, it's a technology that we're going to talk about. Copy commands, how to copy, and you will be spending some time sharing with actually those, well, in the lab with those techniques out there. And actually consider how to ingest and load those data. Okay. Uh, okay, so let's go on now for the agenda. Two lessons here, so it's not going to be a big module. First lesson: use data loading best practices in Azure Synapse Analytics. And second one is petabyte-scale ingestion data factory. Well, let's go on then just on the first lesson. What are the best practices here to use data loading in now we come back to Synapse. Remember, Synapse, don't just maybe I'm gonna do a quick reminder. In the Synapse, you have two parts. Okay, you got your here SQL pool, oops, SQL pool, and from those two SQL pool, you have actually here one which is dedicated SQL pool, and you have on the other side serverless. It's gonna be going off on the other side, but serverless. Yeah. Okay. Let's do like this here. I know it's not a bit. Okay. So the difference, definitely, as I tried actually to explain you yesterday, is that dedicated is gonna be fully, you're gonna have a certain control about your provisioning controlled. So it's not gonna be maybe so flexible as you would like to, right? But at least you're gonna have some control about your expenses at the end of the month. You're gonna know how you're gonna spend your money, and you know exactly what you need. So in terms of, again, it's a good thing, I think, to really all those things. CPU, the RAM, that means the memory. Should I say here memory? And then we're talking then definitely about the compute capacity and the memory capacity, right? What you need there, when you know, then you choose the dedicated SQL pool, and you're gonna then definitely build the data warehouse, and especially if you are actually building one which is persistent, because it's gonna be there, it's gonna be saved. Whereas in serverless, it's an ad hoc. They used to say this Latin word, ad hoc. It's a Latin word meaning it's just it's actually something nearby. It's something not planned. I have like a question. I have an unplanned question, casual question. So it's ad hoc, something I would like to query my data over there, and I haven't had to do that. Okay, but again, serverless is very powerful because it gives you flexibility. That's one part of Synapse. The other part of Synapse is also Spark Pool. Again, I'm gonna insist. You have other thing, but here I'm gonna say Spark Pool, and it's based on the Spark technology. Okay, so in Spark, it just means that we are talking about big data analytics. Big data analytics. And therefore it supports Hadoop, file system, etc., etc. Anything regarding the big data. Remember, with a Synapse, you have the ETL capabilities and Synapse links to make the hybrid architecture between the operational and transactional and analytical context, etc., etc. But I will not dwell on that part of Synapse. So, recap of where we are here now with Azure Synapse, data warehouse, big data analytics, still different kind of pools, okay, dedicated serverless, ETL, etc. So we're ready to go in. So let's talk about first the dedicated SQL pool architecture. Okay. Um, okay. When you use Synapse SQL, your analytics workload runs using a SQL pool. And in a SQL pool, to control the control and compute nodes, okay, that could be like seen like let's say a machine, a server, say, but it's not called a server, right? Because it's not, it doesn't mean it's a server as per se. That's why they call that a compute node. But you can think of like a single server, okay, to start with. So in a SQL pool, those controlling compute nodes in the cluster run a version of Azure SQL database and they support distributed queries. Okay. You define your logic using transact SQL statements. Transact SQL statement is again a flavor of a SQL language. It's a SQL language, but with some, let's say, like in languages, you have dialects. So that's the same thing with SQL. You're going to have some dialect of SQL. And here, transact SQL is one dialect of SQL. So you're going to send your transact SQL statements to the control node, okay? And uh, it's going to split up the work into queries and we're going to operate over a subset of data. So here are the data. So it's gonna split up that between the subset and it's gonna send those smaller queries to the compute nodes. Okay, so actually I was wrong doing that in here. I haven't I haven't noticed here we have the control node. Actually, if I again I'm gonna erase that. I'm doing again this transact query will go to here and it's gonna be splitted into those data query and it's gonna go here, here, here. Actually, they're gonna be here an animation, but I'd like to do it by myself here, so you're gonna see it later on with the animation on this slide. Okay, so the data is split into chunks, and guess what? All those chunks are called distributions. Very important, distributions. And there should be like 60. 60 distribution is the max, if I'm not wrong. Right? And it's the basic unit of storage and processing for parallel queries because it's gonna be in parallel. So that's why we are in a parallel architecture. And that's why actually it's gonna work with big data. Big data at the beginning poses or set a big problem with our common architecture we had previously with just one, let's say, computer not distributed. So it was too big to be handled. So that's why we had to split the query between different servers or computers so we can process in a decent time. Because if not, it would take like the eternity, right, to process the query for this big data thing, like big, huge data we have. And if it would be processed just by one server, one computer, no way. I cannot wait so long to have the answer. We're gonna split that between many computers, many compute nodes, but there is this orchestrator here. It's gonna say, okay, I have the query and I'm gonna split that. I'm here. Here is the manager, he's the boss, and he's gonna split the work between his team, his employees, or whatever you want to, right? So that's the idea here. okay? And it's gonna be done in parallel. So they don't have to wait the team member do not have to wait for other team member to complete the work to get the work done. So that's here the beauty of it, of this parallel architecture. And that's why it's gonna be fast. Okay. So let's see here now the animation. So the query goes into the manager, let's say, right? The team leader, and the team leader split the works between the team members. And as soon as they processed, as you have seen here, I'm gonna maybe go back again. The work has been split, processed, and get back the info, re-centralized, and give back the result because it has to be managed by one. Again, like in the teamwork, it always has to be centralized because if not, it's gonna be big chaos. If these guys tells you, yeah, I'm done with my work. Look, that's my results. And again, these one, you will not know where the results actually, how the whole results looks like, and how you should reorganize the whole result. So that's why this team leader here is getting the result back to you because he knows or she knows how the work was split and therefore to rearrange to get you the whole result, right? So I hope my explanation here was a bit was clear enough to get you the parallelized architecture within the big data analytics, right? Here, the paradigm changed with big data. That's what how the distributed architecture looks like within the big data world. You're gonna work with clusters, with nodes, and you're gonna have, again, I'm gonna come back maybe. You're gonna have one control node who's gonna centralize everything and splitting the work up to 60, actually within the SQL pool architecture, and a dedicated one. Um, how you need to know when you work with Synapse in dedicated SQL pool. Okay, you are working with many computer nodes. It's distributed, and you're gonna be interfaced or communicating with one control node. The other ones you don't have to be worried about. You don't have to know which where they are located, etc., etc. This control node will actually get into that and get the result for you. All right, so what do you think that you have to take into account when if you look at the data load and about its goals, right? That's the question you should ask yourself. Where is my data coming from? That's the first question, okay? Is the data net new, or do you receive changes from existing data sets? How often is the data being refreshed, added, or replaced? What formats are the data coming in? Is the data ingestible as is, or transformations, cleansing is going to be required? So some other tasks to be considered, and therefore workloads. And about the priority of loading data in querying, you're gonna ask that yourself also, okay? Because at the end, what you want from your data is gaining insight, right? So from gaining insight, that's what you need to do and perform. And again, remember what I said at the beginning. There is a bargaining power between the, let's say, source context, should I name it like that? Source, and that means all any SQL databases, any Data source, okay? Any data source you may work with your actually purpose here, which is your analytical context. Analytical context, okay? And that's you. You are here. That's your boundaries. Actually, your boundaries cross over here, definitely. It actually entails maybe everything. Depends of what you need, what you are for up to, what are the requirements. But what you definitely want is you don't want to make them angry here. You don't want that. There is this bargaining power here. So the workload, that's another keyword you should be familiarized with. The workload should be low or as lowest as possible. Okay? Because if you charge those data source here with a huge workload, lots of bandwidth requirements, then remember here we are in the business part, like usually OLTP. OLTP, that means online transactional processing, and that means any businesses transactions that happen are gonna be registered here, saved here. Lots of access, lots of inserting data, updating data, and it can be very massive, and very resource consumed. So it's gonna be very overloaded with lots of let's say, yeah, workload. The workload will be very high, and they're gonna be in priority because we want the business before this analytical, let's say, requirement of your whole business. What what your CEO wants is your business working, right? That's the first thing. And then, if you can afford resources, we want to analyze what's happening and then take decisions, even if it's very important. But first thing first, things has to work for the business as usual on the day-to-day basis. If at some point there is a problem when you're gonna get your data here because you're well getting the for instance sales, right? You're selling online or you're selling in the stores. If there's a problem here, then it's an urgent problem because the business is not then uh, getting done and you're losing money. Here, if the analytical things is not done, then maybe you can do it at a later time, or the decision can maybe done later on, depending on definitely your context, right? Which kind of business you are in. But usually here comes first and then here comes second, usually. So that's why we have to think and to be careful about the workload, what we are requiring from this part of the systems of data sources. Okay, I know I was a bit long about this part, but uh, I was a business analyst, and believe me, this is the most important thing maybe you could answer in all situation. If you understand that the why of everything that you're doing here right now, then you would be on the way to get to be successful, so should I say, because then it's just a matter of knowing how you get the information, how you get the knowledge, how, and the how is very important, but it really relies on the why. Actually, there's something in between the what. But anyway, um, here is a little, let's say, method to definitely get the things done in the proper way, right? By layers. And the highest level of layers is why. why you want everything done the way it is, why the workload here is so important. So you need to understand that first, and then to get the proper. Are you even using here Azure ecosystem? Yes. So that's the what. And in the what, then okay, the Synapse Analytics. All right. Okay, Databricks. Yeah. And then how? Okay, I'm using maybe the SQL pool dedicated, and then I'm using those SQL or Python libraries, etc., etc. But then, yeah, we're going down and down and down. Okay, so um, I'm going into this topic a bit, maybe larger, broad, larger scope, because we're talking here about essential, very, very important questions to ask yourself when you're gonna design your architecture, and in this case here, the data load. Keep that in mind always. Always keep that in mind. Why? Why are you doing this? And believe me, it's gonna save you a great time. If you don't know why you're doing this, don't do that, or investigate at the end. Am I doing this for a good reason? And again, the reason should be very good enough, because whatever you're gonna do as a data engineer is gonna cost money to the firm. I mean, anything in any position, right? But as a data engineer, maybe sometimes it's gonna cost a great deal of money, especially when you talk about those solutions like SQL, dedicated pool, etc. So we need to be sure that what you are choosing and what you are doing is worth it. Um, Having that said, let's come back then to the proper technical things, like managing here singleton updates. Okay. Um, this slide is gonna be built to show you a singleton insert moves through the control node. Okay, it's gonna be allocated to a specific compute node. Uh, a singleton load is a small transaction load, and it can create unnecessary flow of data. Okay. The goal here is to group the append of singleton to insert files and use a faster load option by batch importing. So, for instance, if you have thousands or more singles inserts throughout the days, that's what it means here. Batch the inserts so you can bulk load them. Develop your processes to append the file. Okay. So here we go. Okay. With this singleton. And it's going to be loaded in the compute node, as you can see, through the control node. And again, another one. And let's go to the other one over there. So then you have this batch. And you have the file at the end, okay? So many users would be able actually to get those jobs done. And it's very important to reduce the amount of concurrent access. Okay, because concurrent access means many users want to use the control node, for instance. And this can be accomplished by, well, you either run one load job or you run a minimal amount of concurrent load job. So Azure Synapse Analytics is gonna allows you to create control and manage resource availability when workloads are competing. That's what Synapse Analytics allows you to do. Okay. And to actually make it faster, the load time, you can create a workload, which is named classifier for the load user with importance, so that's one attribute, okay, above normal, or you set it high. Then the workload importance is going to ensure that the load precedence of the overweighting tasks of a lower importance rate. So that's basically prioritizing. And you can use this in conjunction, so together with your own workload group definitions. And that's where your workload is going to be isolated, and therefore you're going to manage minimum and maximum resource allocation during those peak periods and quiet periods. Okay, so here we go, for instance, and these when you had this high, and sorry, I've been fast here, okay, and this concurrent access. Now, using Polybase, copy command and copy activity, there are multiple methods actually to transferring data into the tables of your dedicated SQL pool. Polybase is actually a method, a quite established method, to transfer data from files stored actually in a data lake table that is in your dedicated SQL pool, right? And it can also work with server SQL pools, actually, not just dedicated one. Okay, so Polybase is both dedicated and serverless. The copy command actually has been introduced to simplify the process to transfer the data, and it can be quicker in some instances. If you want to ingest data using the GUI methods, you can do that also. And the copy data activity in Azure Data Factory or Synapse, which is here, has been also introduced. And as I said, the Synapse pipeline is actually based on the Data Factory technology. So if you know how to use Data Factory, you will definitely be comfortable using Synapse pipelines. In this case here, we are talking about pipelines, right? ETL process. Should I mention here maybe it's very maybe sometimes when I started to actually work with and trying to understand the concept of pipelines, I was imagining myself as a pipeline of, the oil pipeline coming from, let's say, the source when you get your things here, and you get the resource to some place, right, when you want to store that. And that's the analogy in the computing science they done here with calling that a pipeline. However, for me, it's a bit not accurate, because in the real life, a pipeline is, I guess, or my imagination, getting or just transporting the resource. However, here in IT context, in this case, it's just the same thing, copying. But you use pipelines to do other things also, like, for instance, cleansing data. You get rid of the rows, you get rid of the columns. You can even use pipelines to change data types. Therefore, there is some transformation happening here. Something is happening. Should I maybe draw like this little, how you call that in English actually? I don't even remember, but there will be some processing performed, right? And that's what pipelines do in the computing context. So in this case, you are just copying, but you're gonna have over actions like changing something, transforming, right? There will be some transform process. Anyway, here we're using polybase copy command. You have a staging table here in the copy command, going to the production. And staging table is an interesting concept also. Staging. It's like in a stage. It's something that is not, it's not forever. So it's getting like some people, well, some in the literature are also talking about sync, but here staging is a bit different. There will be lots of things to say about staging tables, what they are for there, especially used for data warehouse. And again, I definitely recommend you to go to the documentation if you want to know more about what implies a staging table. But here, just remind uh, that bottom line things that it serves to get data from one place to another one. Okay, you're gonna need sometimes those staging tables so you can actually transfer data to at the final maybe destination, which is the production. That's it for the first lesson here in this module. I know a lot of things to assimilate, and to process. Sorry, but yeah, little by little, maybe get all the information and process, getting familiar with the vocabulary also, because some words, as I was, pipelines, staging, you're gonna see other words like sync. There are like analogies trying to explain what we're talking about, but don't be always too trustful or to trust the analogy, thinking that, oh, sink means it's just like a sink and then the water flows and go down. Well, sometimes you may just think about the right thing, the right concept, but I always recommend you to investigate what each word means really, what they wanted to say by that, like SQL pool. What is a pool? What do they call that a pool? There is a difference between, let's say, this SQL database system, like a relational database SQL pool, sorry, relational database based on SQL, and a SQL pool as a per se, the way the constraints are designed are a bit different. And that's why you say specifically, for instance, a SQL pool. You don't say, you are not talking about a relational data system as per se. There's a relational, yeah, SQL for a classical one, transactional one. All right, so that was just a little tip here, but lesson 2 is going to be about petabyte scale ingestion with Azure Data Factory. Actually, this reminds me another course I was actually taking, but yeah, here we're talking about the big scale ingestion. And Azure Data Factory is another component of the Azure ecosystem and is the same as you can have with Synapse, as I mentioned, the Synapse pipeline again. And you might have already experienced, be familiarized with those ETL processes on your own, because many people think ETL is something very complicated, out of the reach. No, it's something like very specialized, data engineer oriented, and seen that, and wow, something very complicated or complex. Remember, it's extraction, it's transformation. Oh, sorry. Yeah, you extract, you transform, and you load. Yeah, definitely transformation, transform, or let's say transform and load. Extract, transform, and load. Extracting, it's like getting data from somewhere. At the data source here, and it could be like an Excel file. You get this table over there in your Excel file, but you need this table, but without those two columns. And actually, please change me the date format to another one. Okay, so you just get rid of those two columns over there and you change the date format. And that's the transform part. And from there, you're gonna copy that into another repository or whatever storage you're using, right? So this is an ETL. And I guess many of you people have done perform that before with an Excel spreadsheet or any other software. But this is something, it's just the idea here. The idea is very simple. Extract, transform, and load. So in itself, this is something very simple. Now, it's getting complex, or it's getting a bit, complex when you're talking about a huge amount of data, and especially if those huge amount of data is not just, or is not unique, or you have to deal with over or many sources. And you just have to take those data and create something to transform them, to rearrange them. And so that's where actually this is becoming complex, right? Because you need to understand how you're gonna get those data, how you're gonna rearrange them, and how you're gonna load them. Because not only many or several sources are used, but those have different policy, different way of being updated, etc., etc. So you need to update your actually data also here. So the way it is updated here is going to affect you, and therefore, yes, at that point, the things get a bit complicated, especially again with large scale data, right? But as per se, this process ETL is not complicated at all. It's those three actions: you extract, you transform it, and you load it. That's what you're gonna see here with, for instance, Azure Data Factory. Azure Data Factory is very good, very, let's say, powerful tool, because the GUI, graphical user interface, allows you to just drag and drop, by dragging and dropping, and with these interfaces just setting things very quickly. You don't have to code. No, you don't have, usually you can actually perform some code things, but you don't have to. You don't need to know how to code. Again, here we're gonna be a quick, let's say, revision, okay, about data slash Synapse pipeline, which is the same thing. We're gonna first need a linked service, okay? Linked services are much like connection strings, okay? So again, here, connection, like in you worked, or you know that within the plumbery you need to connect your sinks with the over part of the whole hydraulic system. So the same thing, we need to make connection first. The same thing with databases, actually. When you want to get into the database, you need a connector. So the linked service is a connector needed in Data Factory or in Synapse pipeline, so you get to the external resources, okay? Since you want to connect to a data lake, or you need to connect to the Azure Databricks. Then comes the data set into the play. Okay, the data sets represents data structure within the data store. Okay, you have your whole data stores that you're gonna connect to, and let's say just about a chunk of this data source. We talked about data sets, and it's actually just a point to reference the data you are gonna want to get as an input or output, actually. Okay, then comes into the play the activities, right? An activity represents a processing step in a pipeline. Again, I mentioned previously, a pipeline is not just a tube where you're gonna uh, ingest some one and O and goes in, that's it. There will be an activity, there will be some processing taking place. So you might use, for example, copy activity, but many other kind of activity exists definitely. Um, well, then you can talk about many different activity regarding the technology used. For instance, a Hive. Hive is a technology used within the Synapse and Azure HD Insight. So it's gonna allow you to transform and analyze your data. Okay. Data Factory actually supports three types of activities, and I'm gonna write it down them for you here. Data movement, that's one activity. Data transformation, that's where activities in itself takes place, transforming data. And finally, data control. So more to control the kind of data that are getting from one place to another one and applying any policies that you want to apply to them. Okay, that's the third component of what an ETL architecture needs. Then the fourth one, the pipeline as per se. Okay, it can have actually more or one or more pipelines. Okay, because a pipeline at the end here is a logical grouping of activities. It's gonna perform perform a unit of work. Okay, together those activities perform a task. So you can have many, let's say, different logical group of pipeline. For example, let me give you an example. The pipeline can contain a group of activities that ingest data from an Azure blob. Then it's going to run on a Hive query in an HD Insight. And then on this HD Insight cluster, it's going to partition the data. And finally, it's going to store those data over there. So the activities in the pipeline can be chained together in certain order because the sequence is going to matter. And they can actually operate independently, like I'm doing my stuff here, or in parallel, because when they're in parallel, they are independent, so they just do their own activities, no matter if the parallel activity ended up or not, or they can be actually depending on the previous activity. So they're waiting for a previous activity to be done, so they get the result, the output, so they can begin their own activity. Okay. There will be a trigger, actually, so that's the pipeline. Okay. There will be a trigger. A trigger definitely represents a unit of processing, and it definitely determines when the pipeline execution needs to be kicked off. Yeah. So there always will be triggers. It can be like the input or the output of the previous, let's say, activity. So the trigger of this pipeline will begin. Okay. Yeah, here is a good. Here goes the triggers. So there's these triggers getting in, and boom, the pipelines begin to work. Now, for instance, here is like, let's see, the animation about one data processed through the pipeline. And we need to talk about parameters. What are parameters? They are key value pairs of ready, key value pairs of data configuration, and we can say read only. You can't change that because supposedly when you set a parameter, you can modify the activities performing with those parameters can be changed. I mean, we cannot change the parameter. That's why it is a parameter. Okay. So there are arguments. Remember when I was talking about the methods previously? There are arguments passed to those, let's say, activities, right? And well, they are very useful because sometimes you can use the same pipelines for different, let's say, data set. If you just need to modify, let's say, I don't know, it could be, for instance, the customer type or any type of dimension you need to use for different kind of data set, but the process is the same. Okay, that's what usually parameters are for. Then we need to talk about the integration runtime. The integration runtime would be something that actually runs your activities, right? Many integration runtime actually on the cloud, but you can run your own runtime on premises. The Data Factory, if I'm not wrong, has its own integration runtime, so it's run in the cloud, but you can set your own on premises. All right, so this is what you need to know about the whole architecture when you think about ETL using Factory or Synapse. Okay, think about those components. You need to have a linked service. You need to have the proper pipeline with the data sets that you want to have and to get as an output, and therefore which kind of activities needs to be performed with those pipelines, which triggers would actually take place, because it can be one time only, or it can be project, or it can be set to be triggered at some point, right? With a threshold or any kind of those triggers. You can think about parameters that you need to put in place, and you need to think about the integration runtime. If it has to be in the cloud, but then think about the security aspect and the control flow, how the policy should apply about the data transiting from one place to another one. Now, here is an example, a screenshot about copying data. Okay, so the build code-free data ingestion pipelines don't require any transformation during the extraction of the data. Okay, the copy activity has support for over 100 native connectors. So you can connect to many data source. This method actually can suit new startup projects that have a simple method of extraction to actually an intermediary data store. So an example of ingesting data using the copy activity, it can include extracting data from multiple sources and actually database sources. and outputting the data to files in a data lake store, for instance. Okay. So when you want to understand, for instance, integration, and talking about the integration runtime, that's what I was talking about previously. The integration runtime is something that you need to consider when you want to know how your data is going to be transiting and what kind of policy you're applying. So when you're copying data between two data stores that are publicly accessible for internet from any IP address, you can use the Azure integration runtime to copy the activity. And don't worry, this integration runtime is secure. Microsoft applies the same security policy as it is in the Azure ecosystem. It is quite reliable and scalable, so you can use your petabyte scale data. And obviously, it's going to be global. So you can do that from one place, which would be California, to another place in India, or any data centers that Microsoft have, right? The other options here is your self-hosted integration runtime that you need to configure on premises when you have those security requirements that it needs to be on your, let's say, on premises, on your local, let's say, local network in your company or organization. We're almost at the end of this module, so those couple of questions will help us to wrap up this module. So first one, which data loading feature limits the number of resources a group of requests can consume in Azure Synapse Analytics? And we didn't touch this point really, so I'm gonna give you the answers right away. But this feature is called workload management. You're gonna see that, and you can know more about on the Azure, on the Microsoft documentation. It's reachable from also the Azure portal. So that's what it called workload management. You can limit the number of resources a group of requests can consume, right? Then the second question, why should you split one large files into small files when loading data in the dedicated SQL pool in Azure Synapse Analytics? Why should you split it up? And the answer is, as I was explaining, the benefits of big data analytics when you're coming to the architecture. This is kind of architecture you're gonna need when you work with big data. So the answer is massive parallel processing architecture. Okay, we want to take advantage of this architecture. Okay, and definitely that's why when you work within Synapse, you need to think about parallel processing. Okay, it's gonna be split it up between different compute nodes, right, between clusters. So the things are gonna be efficient and in a timely manner, should I say. Third question, in which section of the Data Factory Designer canvas would you find the copy activity? You just have seen a little screenshot, I know. Then I definitely recommend you when you're gonna go into the lab to check out, for instance, the Data Factory and see the different, the GUI as it is. And you will see it's not so complicated. You're gonna have several sections, and the one within for the pipelines, you're gonna have different categories of pipelines, and the one for the copy activity is named move and transform. That's it. I mean, well, usually in the exam, it's not required to know by heart how the GUI is laid out, for instance, in Azure Data Factory. But here is an example, right? So you can try to remember, for instance, this one, and how generally the GUI is organized, for instance, for the Data Factory or even the Synapse, right? You just have to Synapse, you use the Synapse Management Studio to make the things done. All right, we are at the end. Again, for this module, we're gonna have a lab for that, ingesting, loading data into data warehouse. All right. So the objective would be loading and ingesting data. Some questions over there, but again, we are now tight on time. And don't worry, you're gonna see all those things in the lab. Now I'm gonna leave you with the lab session. I guess you're gonna have a little break over there, and I hope this was a bit helpful for you. And I'd like to thank you for your time, people. Again, do not worry if you don't get the whole concepts from the first moment you hear them. It's gonna take with time. You're gonna have to get into the concepts again and again until it makes sense, and see some examples, hands-on, handful examples in the lab. From today, that's it for me. Thank you very much, people, and see you tomorrow.